Okay, hello guys. Today our topic is about nuclear radiation. Okay, so for nuclear radiation, we can find here there is just a basic definition about radio decay. Okay, so maybe in your daily life you are finding decay everywhere. Everywhere. Okay, so maybe for like some animals is dead, right? So they will decay, their body will decay, right? And you can say that they gives out a rotten smell, right? And a very bad smell, very like turns the color changes, right? Color changes from the normal color to a black color, right? Or maybe here we can say the decay right here means that, oh, here it emits nuclear radiation. Okay, so we can call this radioactive decay. That means emits a radioactive decay. Okay, so maybe here you can find your some examples. Like we have a stable nuclei like carbon-12 and carbon-13. And we said before that they are isotopes, right? They have the same number of protons, they are the same order in the maybe in the periodic table, and maybe they can become very stable. But for carbon-14, you can find there are more neutrons inside of this. So this structure can be very unstable because it contains more neutrons than before. So for the carbon, it wants to become or just trace back to the original part. So it wants to emit the neutron like this way. Okay. So we can say carbon-14 wants to turn into carbon-12 or carbon-13. So it has to emit neutron every time. Okay. So for potassium, 39 is a very like basic element, and for potassium 40, that is not a very stable isotope, so it is emitting the neutrons all the time. For uranium, this element is very interesting because it's a basic materials or basic elements for the nuclear fission. Okay, you can use it to build nuclear weapons. Okay, very, very dangerous. So we can say, oh, here's the isotopes. Some are not stable, just emit the like neutrons that they can have, where you can say that they're the decay. Okay. So how they're decay? First, we have to know a process called ionizing radiation. Okay. So here you can find there's a simple atom, right? We said before, in a simple atom, we have the same number of protons equals to the same number of neutrons, right? Sorry, the same number of electrons, right? So if you're just emitting for an electron, that means maybe before you have 5 electrons and 5 positive protons inside your atom. Maybe if you release 1 electron, it will form or becomes to 5 positive charge and 4 negative charge like this way. Okay, so total charge here is a positive charge. Okay. So this is for the positive ions. Okay, like this way. Okay, we can say that it is called ionizing radiation. Okay. So like here, we have 3 very classical radiations called alpha radiation, beta radiation, and gamma radiation. So what are they? We can find in this figure, we have an experiment for penetration experiment. Okay. So before this, before understanding the experiment, let's first just discussing some basic understandings for alpha, beta, and gamma, please. Okay. So here is a table. So sorry, I will just remove them all and draw a new table for you. Okay. And maybe we can just discussing the alpha particle, beta particle. Maybe this is alpha particle, beta particle, and gamma particle. Like this, you can use these 3 symbols to represent for this. Okay, here are 3 properties after this. Like first, what are they? Okay, so first you have to know what is it. Okay, so for alpha particles, it means the nucleus for helium-24. It just a positive nucleus. Okay, just contains the positive protons inside of this and the neutrons inside of this. This is for alpha particle. And for beta particles, you can consider it as just an electron. It has maybe for like 1 negative charge, and there's no maybe very small relative mass inside of this. So we can consider about the electrons. Okay. So for gamma, you can just consider about a photon. Photon. Okay, so photons just means a basic unit of the light in our daily lives. Okay, so it's very small and it approximately equals to 0. The mass approximately equals 0. So it's very, very small, very, very tiny. We cannot see it. It's invisible. Okay, so this is the first understanding about alpha, beta, gamma. Okay, so then let's move into maybe for the charge in it. Okay, so we said alpha Remember here, it's not an element or it's also not a substance. It's an ion. Okay, you can find just. Oh, sorry, maybe it's not an ion. Maybe it's like a nucleus. Okay, so we said before like this is for helium nucleus, and here is for protons, and here's for neutrons. Okay, and like here we can say, oh, maybe it's just a positive charge, and here is electrons outside of this. Okay, this is for the structure for the atoms, right? So just we have nucleus only has protons, positive protons, and like neutrons there, no charge, right? So total charge here is positive, right? So here we can say the charges for the positive, okay. And for beta, inside of this, there's electrons, right? So electron just takes negative charge, right? And for gamma particles, there's no charge inside of this, okay? This is for their charge between alpha, beta, and gamma, okay? So next part we will discuss about for the mass or relative mass, okay? So for alpha particles, we can find here, there are four, right? So last time we said before, like four means the relative mass or the number of protons and number of electrons, sorry, number of protons and number of the neutrons inside of this, okay? So relative mass here is four, okay? And beta just maybe approximately equals to 1/1816, okay, like this way. And gamma particles just approximately equals to zero. Or it's very, very small, we can just consider it as zero, okay? This is for relative mass. And after that, we have two abilities. Like here, we have an ionizing ability and an penetration ability. Okay, so I'll just leave it here. Okay. So we can find our particles is very big, right? It has a relative mass about 4. Okay. So you can just consider a scene like here. If a person just wants to cross the door like this way, okay, the person just wants to cross the door. So he wants to walk through the door, right? So if his body has a very big shape, okay, maybe his is more right. His body is very big. Or maybe he passes through the door, it will be blocked, right? Because he's very heavy and he has a very big voice, right? So it will be blocked by the door. Okay, so he'll try his effort to pass through the door, and he'll find maybe the door is broken after he passes through it, right? So we can say just like the alpha particles is bigger than beta and bigger than gamma, right? Because you can find the relative mass is very big. So like after it passes through an atom, it can make the atom like the door broken, right? The atoms just like forms the protons and electrons, they'll just be broken, okay? Before they are atom, right? After the alpha particle passes through it, and you can find the electrons is moving away. Okay, it's just like a door. Total door contains protons and electrons, and the alpha particles goes through this, and the electrons just falling down like this way. Okay, so its ionizability is the strongest. Okay, like this way you can remember this very clearly. Okay. So for beta particles is a middle size, right? So its ionizing ability is just middle, okay? And for gamma particles, its ionizing ability is very, very small, okay? But you can find there is a difference between this. And for the penetration ability for alpha particles, we can say alpha particles is very big. So it's very hard for it to pass it through the door, right? So its penetrating ability is very, very small, okay? So it's very, very, very small ability for alpha particles to penetrate, okay? And for beta particles, we can say, oh, maybe it's also the middle size, so it can pass through the door, maybe the middle ability, okay. And for gamma particles, very, very small, so it can have a biggest or uh, the strongest ability for penetrating, okay. This is for their ability and their meanings of alpha, beta, and gamma particles, okay. So please remember this is very important, okay. So there is a experiment we said before, like here, like you can find alpha particles cannot even pass through a paper, right? A very short paper. And for beta particles, it can pass through or penetrate the paper, and because it's middle size, but it cannot pass through the aluminum. Okay, I find this. You can find the gamma particles is very strong and very small, right? So it can pass through the paper, aluminum, even a very like maybe not very thick lead like here maybe for 3 millimeter or 2 millimeter like this size, and it can pass through the lead. Okay, so gamma particles have the most like ability for penetrating. Okay, so this is for alpha, beta, and gamma radiations. Okay. So after that, here is a total table for you to understanding for the gamma, alpha, and beta. Okay. here is how they are, and with their charge, mass, speed, analyzing effect, penetrating effect, and even effects of the field. But remember that IGCSE doesn't make you the understanding for the effects of fields. Okay, so you just need to understanding like the mass, related charge, analyzing effect, and penetrating effect. They are very important for you to master and to solve some problems. Okay. So here we can find, like we said before, if you have a current, if you're putting it into a magnetic field, it will have a force, right? The force given by the magnetic field. So all like this way, you can find alpha particle, gamma particle, and beta particle if they're putting in a magnetic field. Like alpha particle, like moving forward, you can just consider a positive charge moving forward. So it's just like a current direction. So we can say, oh, here's the current just moving like this way. So please like raise up your left hand using the left hand rule. You can just using your thumb to represent for the force, right? And the first finger represents for magnetic field, and second finger represents for the current, right? So here you can just, oh, here N for S is just towards the paper into the interior screen, right? Like this way. And you can find your second finger is just moving like from left to right, right? You can find your force is moving where it's just upward like this way. Okay. So our particles will have a deflection just like moving upwards. Okay. And for beta particles, you can also use it this way, but remember that beta particles is electrons. Okay. So electrons moving direction is like an opposite direction with the current moving direction, right? So here the current direction is from the right to the left. Okay. So here you can stretch out also using your left hand to represent for this. And here you can say, oh, like the fourth means the thumb, and second finger means the magnetic field, and the third finger means the current direction. Okay, you can find that there's a force downwards for the beta particles. Okay, because the current is from the right to the left. Okay, and you have a deflection like this way. Okay. And for gamma particles, it can moving straight because there's no charge for it. So it doesn't like any current, it has no charges, it's just moving through like a very straight line. Okay, so this is for the difference between alpha, beta, and gamma radiations. Okay. So after that, we have a discussion about radiation dangers. Okay, so for our daily lives, like some like radiations is very dangerous for us. Like if you're going to the hospital, you will find some examinations that need the radiation or need the gamma radiations, right? So it will give you a signal or a symbol on the door like this way. So it means that there's a nuclear radiation. You have to just maybe keep you away from the door or keep away from this room. Okay, so this is radiation dangers. So maybe for our daily life, we are just like hidden the radiation substance under or beneath the ground like this way. We just make them buried in the ground. Okay, so we can just produce ourselves and like reduce some radiations. Okay, like this. Okay, so we can use this to protect us. Okay. And remember that in our like a world, there has a background radiation, that there is a constant value. Ultimately, it will also a constant value. And this depends on your position. Like in different position, background radiation will becomes different. Okay. Maybe in some places near the mineral places, you can find there maybe a very big background radiation. That means there are many substances which has the radiation, okay, that gives out the background radiation. So here there's a also like a apparatus to measure the radiation. Like this way, this is called a like GM tube. Okay, so for the GM tube, you can find how to detect this. The radiation first passes through this, okay, and it detects if there's alpha particles, beta particles, that it will go through here and like that touches the surface, okay, and the radiometer or scalar can just determine what is the readings on this, okay. So if the reading is very big, means that there are more alpha particle or beta particle that touches through the surface. Okay, that means like the background, that means the radiation, total radiation here is very big. Okay, so sometimes you will put a source right here, just to measure the radiation from the source. Okay, but remember that we have said before, we have a background radiation, right? Okay, so if you just like left it as a blank, there's no substance on the left, you just measure it, okay, there's still a radiation that is from the background, okay. The background is always filled with different kind of radiations, okay. So you can find there's a radius, maybe 6 or maybe 5 on it, okay. So maybe if you put the source on this, like on the left, and you will have a reading about 57. So please remember that you have to using the 57 to minus background radiation is 6. Okay, and here the radiation for the sources maybe for 51. Okay, this is very important for you to understand that always remember there is a background radiation in the environment. Okay, very important. Okay, so here is an exercise for you to solve the problem and to check whether you are understanding for these problems. Okay, so trying to solve the problem, please. Okay. Okay, so I guess you have an answer, right? You can find here, gas can like pass through the plastic, but can not pass through the aluminum, right? And Y cannot pass through the plastic, and Z can maybe pass through plastic, aluminum, and even pass through several millimeter of lead, right? So we said before, like alpha particles is very big, it means helium-24, right? So it's very big, that means there is maybe very small radiation or maybe very small penetration ability for this, right? This is for Y. And for X, it cannot pass through like aluminum, right? So it is a middle size, and because this is for the electrons or the beta particles, right? This is for alpha. And for Z, it has the strongest penetration ability, so these gamma particles, and it means that N01, right? This is for the Z, okay. So we can say, oh, here X and Y and Z is alpha, beta, and gamma, okay. So here X is beta, and Y is alpha, and Z is gamma. So finally, we choose B as our final answer, okay? This is for this part, okay? And here's another exercise here you can find. Let's do it together, okay? So it is that in a laboratory, a detector of ionized radiation records an average background count rate of 8 counts per second, okay? So here, 8 means, oh, sorry. Okay, so today my app has some problem. Okay, 8 means the background radiation, right? And here you put a radioactive source, like here, radioactive source, and your final readings is 200 count per second, right? So you can say, oh, maybe here the background is 8 and the source have a radiation. So our source plus our background, that the total radiation is 200, right? So here is 8, and maybe here the readings is 192 like counts per second, right? So finally, we are choosing B as our final answer. Okay, 192 counts per second. Okay. So this is very important for you to understanding for about the background radiation and about for the like readings inside of this. Okay, so source radiation added with background radiation is finally the detector's reading on this. Okay, and also to remember that there is a very big difference between alpha, beta, and gamma particles. Please try to understand them and try to take a note for the tables. Okay. So this is for today's lesson, just discussing about like the different particles and the background radiation and for the simple radiations. Okay, so see you next time. Bye.